Hello, hello, hello. Good morning, good afternoon, good evening, whatever you are. Welcome to the Java Champions Conference. If you can see me, if you can hear me, say hello in the chat. Say that everything's good and fine so we can continue. Today we have a very, very special guest. So I'm just waiting for you to confirm that everything is good. They can see everything so we can get started, right? So our special guest today is a new Java champion, right? He's not, he's with us just for a few months now. And let me see. Is there anyone? Well, I see lots of people already watching us. So hi, Jan. How you doing? That's great, Jan. You got the dubious credit of being the first person to say hello. So good. That's good to see you here, right? I see Maristela. Hi, Maristela. How you doing? So good. All right. So without further ado, then let's get here. This guy that's a great friend of mine. We go along for many, many, many years, and he's a new Java champion. With you, the one and only Professor Isidro.
Hey, Isidro. Hello, Bruno. I love your enthusiasm.
Yeah, it's out. We have to be enthusiasts to watch amazing talks, right? So Maristela is saying here that she was the second person to say hello. Thanks, Maristela. That's great.
Sebastian is my student, right?
She's your student. Yeah. All right. So that's the right way to do, right? So here's a tip. If you want to have if you have a professor, you want to have a mentor, here's my best tip. Get close to your mentor.
Yeah.
Right? Go where your mentor goes. Meet the people your mentor meets, right? Come to watch the talks. Be close to your mentor. Maristela, you're doing the right way. Hey, so hi, Ambu. That's great to have you here, Sebastian. All right. So without further ado, Professor Isidro, he's, as I said, he's a new Java champion. He's a university professor. He is, he has an amazing focus on the fundamentals, right? So he has lots and lots of trainings on YouTube about compilers and data, data structures and all the fundamentals. And so he's working very closely to get the fundamentals right for students, but also for professional developers. So without further ado, with you guys, Professor Isidro.
Yeah, thank you so much, Bruno. And thank you, everyone who is here with us at this conference. For me, it's a great honor to be here. I'm a very user of J Champions Conference, and for me, it's like a dream coming true to be here to talk to you. For those who know me, Bruno, can you share my screen, please? I'd like to. I did some notes of this topic because what I am intending to do. Let me try to understand. I'm a university professor. Okay, I'm on the academic side, for example. And why is so important to understand fundamentals? Why? Most of times we are used to learn how to use a framework, how to apply a different technique, how to use some kind of technology. And some of you who are watching us right now, are you curious about how these technologies are implemented internally? Because why this kind of question? Why this kind of why am I questioning this? Because you could be very, 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 I could say, profitable on coding, and you have to improve and increase your technical skills to know how those technologies work internally, and it will make you a better developer. Let's try to do some examples and to connect some dots. Let me see. Let's try to do something. For who doesn't know, nice to meet you guys. I'm a professor, I'm a researcher, I'm a speaker. I used to say that I have a YouTube channel. I'm not a YouTuber. Why is it true? Because I don't know how to. Please subscribe. Please click on the sound bell. Like share everything. I don't know how to do this. I use my YouTube channel to make my classes. That's it. And one curious, I have a platform that I teach Java and all of these fundamentals besides YouTube, and that uh, we nominated this as Easy Flix. The Professor Isidro's Netflix, like this, something like this. My students give this name. And one curious thing, the three first letters of my name, ISI, here in Brazil sounds like easy. So many people call me, "Hi, Professor Easy." And when I realized that, I promised to myself, I must make all difficult technology make easy to explain. My students must have the easiest way to understand complex concepts. That's my mission. Okay? Quoted mission. Right? Right. So, before we start to talk about graph theory and how this is applied on our favorite frameworks, who here at the chat and who's watching us remember of those technology, EJB? Guys, I don't know if you are new or if you are old school Java developers, but when someone tells me, "Oh, Java is about to die," no, Java is not dying, and that's a fact. But in this case, I was afraid that Java was about to die. Why, Professor? Because when let's see, I think it's in about 2005, 2003, we had these technologies. Oh my God, it was very difficult to be politically correct. It was very, very, very difficult to work with enterprise Java base. Why? Because you have lots of XML files to configure. First, mainly version 1, version 2.1, and version 2 was very, very, very easy. But though these difficulties, these problems that we faced in this time make lots of uh, lessons, to good lessons of how can we make our partners, our developer partners, a little bit easier to code. Why? You had in this time you had to have an EJB project and an application server, and these guys must talk to each other. Could be in the same container, could be in separate containers, and it was a hell on earth to put an application fully implemented in using EJB running. Right? It was very difficult. So I think Java was about to die at this time, and I was a very, very, very afraid. But, which kind of lessons did we take from all of those difficulties here? Okay, let's try a little reflection. Let's keep away from the past, and I tell everyone I meet, my students in most cases, for of course, study, and that's my advice: study computer science fundamentals. Why studying fundamentals? Oh, is it I have lots of frameworks, lots of libraries, lots of tools to be more productive, and that's a true fact. It's right, it's okay, and you have to use frameworks, you have to use libraries, you have to use toolkits. But let's make a parallel. You drive a car, right? you know a little bit about your car, the right time to, for example, to change your gears. How can you full your tires? If you do simple uh, steps with your car, you can increase your lifetime vehicle. You can uh, use it more effectively, and you can, for example, optimize some resources. You spend less gasoline, less fuel. You can be drive for a longer time, and so on. So if you know a little bit about your car, you can use it better. And the same thing applies to using a framework. If you know a little bit about how your framework works internally, you can use it more effectively, more optimized way, in a more optimized way, understand anything, everything that happens on the backstage. Okay. But how do we start studying fundamentals? I think it's a big problem, obviously considering each one conditions and circumstances, but I think this drawing is very, very, very real. We have data. Okay, lots of data. We have, if you make a Google search about dependency injection, for example, you will know lots of websites, lots of blogs, lots of papers, lots of videos. But how can you filter this? If you have lots of data, you can filter these data on information. What is useful? What is useless? Okay, this kind of information, when you try to connect some information, you have your knowledge. You make your knowledge because you are connecting some topics that can, for example, solve your problem. Okay, but if you have two different subjects that in a first way they have no connection, you have, for example, graph theory and web framework. In a first way, in the first contact, they have absolutely no connection, because on university you will study graph theory and you are trying to understand the algorithms and all the graph representation, but some of these algorithms can be very useful on a web framework. And when you this kind of path, this wisdom can be more effective to improve your capacity and your development skills, because you can connect intermediate nodes to achieve how to interact this topic to this another topic. So this can be very useful for us. Okay, so let's turn back to the talk subject. Okay, what is graph theory related to web framing? For example, dependency injection that we suffered with EJB. The first step of dependency injection, your framework needs to discover objects and interface implementations. In the beginning, on EJB technology, you have XML files to describe each thing: request beans, session beans, stateful beans, stateless beans, and so on. But if you have a web project on your machine, on your IDE, we can use an algorithm that we study in the second class of graph theory, called depth first search. Let's see something. A classical graph search is like this one. But how can we connect those concepts? Because it's a hierarchical notation, and you have intermediate nodes and leaf nodes, right? Right. How can we connect this to our web framework? Let's see. Connecting the dots. Keep this in mind, okay? The DFS algorithm uses a key concept in most cases, most students. Why am I doing this? Just a parenthesis here. I'm supposing that I'm talking to my students also. My audience is here in YouTube is my students at classroom are the same people. But when I teach recursiveness, lots of students only think about the factorial algorithm. At most, for example, a vector sum, at most. But this kind of algorithm uses recursiveness in a very, very, very intense way. Why? Let's try to connect this concept with recursiveness to discover classes and implementations. For example, your Java project has packages. Packages are folders on your operating system. Okay, packages contain Java classes and other packages. So here we have a recursive definition. Okay, so if we use DFS algorithm, we can traverse all packages, getting all classes names. And we can do this in a very, very, very simple way. For example, with a 10-line algorithm, we can do practically everything here. We can make all the discover of our classes, interfaces, implementations, objects, beans, and whatever using our classical algorithm. We are trying to connect an algorithm to traverse a project in order to make an important step on dependency injection. For example, the lookup, the class lookup, in the implementation lookup, for example. So, in the second part, we can use Java Reflection. That is not a new concept. It's about Java Reflection exists since JDK 1.1. We can retrieve all metadata from our classes. Class name is class type, class definition, inherited interface, implemented interfaces, inherited classes, for field names, field types, field annotations, methods, and anything. We can literally hack our classes. And that's the main point, the key point of our goal in this talk. For example, if we combine depth first search, the second class of our graph theory subject, and reflection API, we can have object discovery and object instantiation, and for consequence, dependency injection. How can we do this? Well, let's see. How does this magic happen? Of course, Professor Isidro didn't extract these from his mind. We have a specification here. We have a spec. The Jakarta EE explains how the dependency injection work. Okay, how the CDI work in this document. Okay, let's see something. In this kind of project, and later I will show the code, I divided my dependency injection in 3 steps: lookup, metadata exploration, and lifecycle management. Okay, the first step, lookup. Basically, if we have, for example, a project, a simple web project based on Spring. Spring framework is like is some Spring framework or Quarkus have the practically the same structure. Okay, so we have the root package, the base package, and sub packages inside it. And inside those packages, we have controllers, we have models, we have services, and so on. Okay, the DFS algorithm gives me a list of all classes that I have in my project. All classes. From this base project, we can extract anything, right? Right. So if we have this class list, I can extract all metadata from those classes. For example, one curious thing that we can find on specification is this one. If I have a class that extends another class and implements another interface, our bean type then can be managed by our container have, for example, at least 3 different types. The class itself, okay, the superclass, okay, business, for example, because Bookshop extends business, so I can declare a reference, a business reference, and instantiate a Bookshop object, and interface, because we can do the same, right? Object, I don't treat at this moment, right? Right. So if we have this specification, I can use this on my way. So if I can extract anything, Java Reflection Law allows you to extract all desired metadata from class definition. And in this case, I want to extract those things. For example, inherited classes and implemented interface. I need this. Annotations, class annotations. Field, all field information, type, annotations, and modifiers. Methods, method name, method annotation, return type, and parameter list. I need at least those information from all classes that I have on my project example, right? Right. So how can I do this? How can I manage my, now I'm going to name it my easy dependency injection mechanism. If I have this kind of declaration, public class full extend bar implement J, right? Right. I can populate a table when I have, I call it the metadata map, and I have on one column all declared attribute types, full bar and J, and in the other column, which kind of class instance. If I declare any kind of field with full type, I will instantiate full class. If I have bar declared, I instantiate full class. And if I have a field with J type, I instantiate full class. In this case, independently if it's the class itself, the superclass, or the interface, all the objects instantiate are usually the same, right? So this is just for class exploring, right? In this case, I am just trying to traverse your project, to look up anything you have in this project and try to assemble my internal structures, right? Right. And for sure, here now, the lifecycle management. So if I have another class, my business class, and in this point, I created some custom annotations, I can declare, for example, private J service interface, and I have a method, do something, and return, for example, service interface dot method execution, right? Just this. For example, my method returns a string, right? So I can identify that this field is annotated with my own annotation. And I can look up in my table which kind of declare the declarement I have. Oh, it's a J declarement. Okay, which kind of object declaration? Sorry, which kind of object that I have to instantiate? This kind of object. Okay, with Java reflection, I can have another table, another map when I have this kind of class type. I have a factory, for example, or a singleton implementation, or a pool implementation. It's free for you, it's up to you. And I can instantiate an object and point this reference to this object. How can I do this? With Java reflection. Okay. It sounds some kind of abstraction. For example, I can think, oh, Isidro, it's a little bit abstract about this, right? Right. But let's show me the code. I think it's the best way to understand anything. Let me open my Eclipse, right? I develop. Guys, it's okay. The font size for you, it's okay. Please tell me on the chat gently. All right. So I started to do my Easy Spring project. If you're not Brazilian, if you're not Portuguese, if you don't read Portuguese, you can say that ISI Spring. Hey Josh, please don't be angry with me. I copied Spring Framework, right? Okay, but it's just for educational purpose, right? It's not a product. I'm not a concurrent, a Spring concurrent. I'm not. I don't want to take place on your framework, right? Okay, so let's try to do something, to see something. What did we do in this project? I defined it, for example, an annotation, easy body, for request body. For example, easy controller, easy get method, easy injected for services, for dependency injection, mainly, easy post method, and easy service. Only this. Okay. Oh, is it we are not handling storage? No, at this point, I'm not handling storage, right? Right. What do we do? If we have Jakarta EE infrastructure, I need to have a servlet, right? That my easy dispatcher servlet. What happens here? What happens here? What's the main goal of a framework? Let me see. Let me show you one thing very, very quickly. I forgot to do this, and I'm going to open another this kind. It's in Portuguese, but sorry, because I was not planning to do this. This title is How Anything Works, How Everything Works, right? Right. You have your framework, and you have your Rabbit project, and you have in your framework, embedded on your framework, our application server. We are using Tomcat, embedded Tomcat. Okay. Connected, running on this Tomcat, on this container, I have a dispatch servlet, because this kind of servlet are going to handle all requests that comes to your application server, right? Right. This kind of this, this kind of framework extracts from your project all metadata, right? And that what I did with DFS algorithm and Java Reflection. So when you and I, of course, assemble my data structures, and when I receive a request, I can queue and I can get on these structures what are the best action to do, invoking some kind of class or method on my web project. How can I do this? Let's get back to Eclipse. In this kind of uh, controller, in this kind of servlet, sorry, I can get all of information when I, first of all, get all controllers, when I can, for example, inject dependencies, when I can, for example, get parameters from our methods, for example, and in this kind, I just start a Tomcat and put this kind of servlet. Let's try to run. Let's try to run. Okay. Before running, I have to tell you, my web test application have, for example, the same structure of a Spring application. Is Spring web application.run. Why am I passing as an argument my application? Because from this kind of parameter, I can retrieve the package name, and I get the base package, and explore all metadata. That's my method that explore all my metadata. I have, for example, a class explorer that retrieve your class. For those who are used to Java 8 to 21, this code looks a little bit verbose, and that was intentional because I try to make it more readable as possible to my students, right? Okay. So what we do here, this retrieve all classes, I have from this, basically the package explorer that recursively traverses all those packages and subpackages, and I add to a list all the class names. A string list, only getting all class names, right? Right. So, in the first of all, if I run this project, you can see I have a controller that is annotated with my custom annotation. This controller has a service that is annotation with my custom annotation, and this controller has 1, 2, 3, 4, 5 methods. Some of them get methods, some of them post methods, but this one, let me see. Oh, here, injected public string, say custom message. What is this? What is this? This one is a service that has an interface, easy service, that has this kind of method, say custom message, and the implementation that's I annotated with easy service returns, for example, a prefix to my message, right? Right. How can we run this? Let me see. The first thing, wow, it's fast. It's fast. I try to call anything is a copy, right? Right. This is my easy Spring, right? And I have a custom logger here. For example, I started my web test application. Right. I started my uh, custom private, my custom class from my web project. Right. So when I try to explore these guys, I can find a controller that is this class, hello controller. I can find a service implementation, that EI service implementation, and this class implements this kind of interface. Right. And I start my web container, and I measure the time spent. Right. Right. So in this kind of thing, I have a web application running that expects any kind of, for example, any kind of request. And let's do an example. Okay, if I have a controller, let me see this kind of controller. Hello controller. I have this method hello. Let's try. Localhost 88 hello. Whoa. Oh, sorry. HTTP hello world. Let me see what happened here. My application, my log is stuck it here. Right. So I received a request in this kind of URL get. Okay, hello in method get. Okay, what's the class handler? This kind of controller in this method. Say hello world. Right. All of this with Java reflection. So this kind of class don't have an instance. So I had to create this kind of instance. And when I created this controller, I look at inside it, and I found an injected field. Oh, so I have to use my techniques to look for any kind of implementation of this interface. So injected serve field has type I service. So I have no implementation of the couldn't find an instance of I service. So I have to look for some kind of other class which implements I service. Okay, I found I service implementation. Whoa, what do? I create a new object and put it on a map. Just this. So injected a new object, injected the object successfully, and I invoke this method, say hello world. But Isidro, you injected a field, but you don't use this. Don't worry about it. I can use the injected, and it puts the easy hello world. I can use a custom object. Wow. I can return an object, a product object, a computer, okay? And I can have the result of this execution. I find the URL. I can determine which kind of method in which class that I can execute this request and anything. Isidro, can we make a live example? Right. Let's do another controller. Let's make another class. For example, JCJ controller, and this kind of implementation, easy controller. That's it. And I can, for example, easy get method. For example, JChampions conf. So public string say hello to J champions. Okay, return hello world from J champions conference. That's it. I'm going to clean my console and start it again. Whoa. I found two controllers. That's it, J controller and hello controller. And now I can test. J champions conf. That's my endpoint. Okay. That's it. Hello world from J champions conference. What's the main point? This kind of controller doesn't have any kind of injected field, any kind of and doesn't have anything. But I can create a new instance controller, but I don't have to inject any kind of object. I don't make, for example, dependency injection. Isidro, you are saying that you are doing dependency injection by on demand. Yes, in this case, I can do this on demand. I could make all, when I extracted all metadata, I could, let me make it a little bit bigger. Okay. When I start up my application, I could retrieve all kinds of classes. For example, controllers. I could instantiate all controllers on startup mode. I could instantiate all of dependent, all this kind of easy service objects on startup mode. It's a kind of it's a choice. It's a choice. You can do on demand on running time, or you can do on startup time, for example. Or you can do on build time, like for example Quarkus does. And all of those concepts makes me understand much more how my web frameworks, work internally. How can they handle, how can they deal with requests? How can they handle, let's do another test. For example, I'm going to use Visual Studio Code with the Thunder client REST. Let me see here. Wow, let me close some tabs here. Just 1 second, please. Okay. Look at this, new request. For example, why? Okay. HTTP localhost 8080 / let me see one endpoint, one post endpoint. Hello controller. This, oh no, this one. /produto. Okay, so okay, what's my request body? Look at this, request body. Expect an object of kind of type produto. What's produto? Let me see, this kind. It has ID, name, price, and picture link. Okay, let's make it. ID 1 2 3 4 5 6 7, right? Name mouse, computer, computer. Okay, computer. I'm not creative with tests. And price. Let me see. It's a double value. Okay. 175.8.65. Oh, sorry. Okay. And picture link, PNG, right? So this information will be sent to my endpoint. That's the status is okay, and I received the request body object. Here, I could put the, let me see, the hello controller here. I could invoke the method correctly. So it's a very, oh, sorry. Post method, not get method. Easy draw. Right. It's nome, not name. 1, 2, 3, 4, 5, 6, 7, computer, price, and link for link picture. That's my product. ID, name, price, and link. Look at this. Found a parameter from request of type Producto, and this is the content of this parameter. So, I think in order to understand anything, let's get back to our presentation. About some conclusions about all of this. Nothing that I did in this project is new or innovative. I don't consider anything that I did new because Spring does this, Quarkus does this, Micronaut does this. Lots of web frameworks can do this, but in this project, I tried to connect some dots. And I think the most important thing is just not about connecting only, is to explain the full path of how can you connect those dots. Because the way I did to connect it can be different from, for example, the way you did if you try to replicate this kind of project. All those resources available since Java 1.1, 1.2 can make miracles to your code. Most of new technologies can be a different way of using existing technology, quoted old technology. Most of innovative solutions can be done with old resources and a little bit of study. And I think the main lesson that I learned with this project, the academic background can make you do incredible things. Of course, we cannot stop in this project. For example, I have some future work. I have the easy Docker. I can make my Docker clone in C language, not in Java, okay? But I can make a Docker clone. I can make the easy PA, my own persistence API. Not just a lib that with reflection I can translate field names and field values to SQL language. I can make, for example, a connection management. I can make a pool of connection. I can make, for example, an entity that to each request, to each persistence request or query, I can give a connection and try to handle all of those connections. I have the other project, the EasyRocco. EasyRocco is this machine behind me because I'm going to try. We are going to do this, but with a shell script, I can receive as input a GitHub link, and I can check out this repository, build, compile, test, and build, and make a Docker image and start a container about this with only one shell script. And the last one project, the Easy FEF, the front-end framework. For example, Java programmers, I don't know, but we like Angular most. The Java programmers that try to be front-end developers prefer Angular framework. And how does Angular framework works internally? How can I change, for example, the router outlet to render another piece of my HTML component? It can be a very, 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 very interesting and challenging task. If you know how to handle the document object model, and if you know a little bit of JavaScript, you can make a front-end framework. Is easy? Not. It's very, very difficult, but it's possible. What's the main message? Two messages that I can give to you with this talk. Your academic background can make you do incredible things, and all of those technologies, all of those projects are projects that are possible and worth if you want to increase your dev skills. Thank you so much, guys. If you want to talk to me, my Instagram is Professor Isidro. My YouTube channel is Professor Isidro. And I'd like to thank you, everyone who was here with us. So, Bruno, we have 36 people watching here. Is that right? Wow. Lots of people watching our talk. Thank you so much, guys. I'm very honored with this opportunity.
Congratulations, Isidro. That's great, man. That's great. So we have lots of people saying that was great talk, right? So, Bear says great teacher Isidro. Someone else say top notch. Boo said excellent talk. Max says congrats, right? Amazing talk. Sebastian says thanks. Lots of people here. Actually, you have a fan in your student, right? So she says, Teacher Isidro, the greatest teacher in the world, right? So that's great. that's
very, awesome. Very, very nice.
So, guys, if you have any questions, this is a good time to ask any questions. We still have some minutes here. If you want to do that. Max says, that's the reason why it's so important to have a strong foundation. It allows us to do more with our tools.
Yes. And it's possible to create, for example, you can create a command line tool to make, for example, a scaffold of a CRUD project. Based on your SQL script, you can make, for example, controllers, you can make models, you can make services, you can make repositories based on a command line command. Wow. For example, Easy Spring create project from SQL file. Anything created. Amazing, amazing. You can create this as a test. It's very nice. It's very nice.
That's great, man. And you like to do those experiments, right? So there's one. Yeah. So there's one comment here. Ian says yes to the history lesson, right? So Isidro, do you think that knowing the history of computers and knowing all this basics, because today everything's easy, you can just kind of download Spring, for example, just use it. But do you think that knowing the history, knowing the fundamentals like this is important for developers today?
I think because all of facilities that we have today mainly are results of everything our colleagues, our partners work very, very, very hard to bring those facilities to us today. So to know about how technology evolved a long time, it's very important mainly to understand which kind of decisions that were made to make the tools, frameworks, and leaps that we have currently. So it's not about only know history. It's about know how concepts were applied and which kind of decisions were made to make our technology know to be in this kind of state of art that we have currently. I think that's the main point. It's not about only just knowing history and which kind of decisions of all previous concepts that were studied before.
Right. That's awesome. That's awesome. Okay. So if you want to follow Professor Isidro, he's there. Professor Isidro on YouTube and Instagram.
Yeah.
A lot of your materials too in Portuguese, right, Isidro?
Yeah, I'm translating
Plans
so
for
many
English.
things.
Yes, what are your plans for English so people can know about that?
I'm currently I have so many materials in Portuguese because most of my students are Brazilian guys. So I told Bruno when I always say I didn't decide, I didn't choose to be a Java champion. I was chosen, and with great power comes great responsibility. And one of my goals in this year is to translate and to create lots materials, both in Portuguese and English versions. So why? Because this kind of knowledge, for example, graph theory linked to web frameworks, can be useful to anyone in the world, not for my Brazilian students. So anyone in the world can make this uh, more next to you and can contribute with this project because all of the GitHub links of these frameworks will be available at my repository.
All right, man. That's great. Okay, guys. So I don't see any more questions. Isidro, I think you answered everything. So thanks so much.
Thanks a lot, Bruno.
Isidro, and for you that's watching us, thanks a lot for being here. Today is the last day of the Java Champions Conference. So we're in the very, very last talks. I think there's just one more talk that you can go and watch. But remember that you have access on YouTube to all the talks that happened this year and all the talks that happened previous years too. So there's a lot of great material on the Java Champions Conference YouTube channel. So thanks so much for everyone here. Thanks a lot, Isidro. It was great to have you here, man. Thanks a lot.
Thanks a lot, guys.
Sebastian is saying thank you for hosting. Thanks a lot, Sebastian.
Thanks a lot, Father Sebastian.
Yes. Thanks,
Bye-bye,
everyone.
guys.
Thank you.